All right, guys, here we go. 6-1, law of sines. You will be able to use the law of sines for oblique triangles. Find the area of oblique triangles, and you use the law of sines to model and solve real-life problems. Okay, so this is part 2. All right, we got another case, and here is where we have no solutions, because if you look at the sides, it's not going to work. And you can go ahead and use the law of sines and check it out, but you can see just by looking at it, it's not going to work. And then for your checkpoint, you're going to find the exact same thing. So let me show you how they worked. The first one here, so if we did the sine of b over little b is equal to the sine of a over little a. So if we know little a is, well, we can just plug all this stuff in. So the sine of b over 25 is equal to the sine of 85 over 15. And when you cross multiply, you've got 15 sine of b is equal to 25 sine of 85. Therefore, your angle B would be 25 sine of 85 divided by 15, and here you want to find the sine inverse. And when you try to plug that in your calculator, you get an error. All right, the checkpoint is also not done. You can't do that one, so let's move on. Those are good ones, right? Okay, so here we're going to look at where there's two possible solutions. So let's just start solving it. We've got a, b, and a, so we know we can do 12 over the sine of 20.50 is equal to b over the sine of b. Cross multiply, 12 sine of b is equal to little b, oops, I'm sorry, which is 31. Why are we not putting that in? We need to put that in, which is 31. So little b, which is 31 sine of 20.50, and therefore if we do the inverse sine, if we do the inverse sine, we get b is equal to the inverse sine of 31 sine 20.50 divided by 12. So b is approximately 64.78 degrees. Hold on. Now if you subtract those two from 180, so we've got what c is equal to is 180 minus 64.78 minus 20.50. So now we got c is 94.72. Which means we can now do our formula of, let's see, we have a, so we've got 12 over 20.50 is equal to c over the sine of 94.72. And again, if you do all your math just like we did before, I'm going to skip over that, then your little c would be equal to 34.15 meters. Okay, so for my second angle, I would go 180 minus 64.78, which would give me 115.22. So now I've got those two angles where I can solve too. So now I know that c can be equal to 20.50 minus 115.22, which would give me 44.28. That would give me my c. So now I can go ahead and plug that in and find little c. So again, I'm going to stick with what I have. So I've got a, so I've got 12 over 20.50 is going to be equal to little c over the sine of 44.28. So your little c is going to be approximately 23.92 meters. Okay, go ahead and pause. You can go ahead and give the checkpoint a go. And for this one, you should have got the first B 70.4 degrees, which makes C equal to 51.6 degrees, which makes little c 41.16 feet. And then your second B would have been 109.6 when you subtract it from 180. So your little c would have been 12.4. I'm sorry, your big C degrees. Your little c would have been 1.14. All right, let's keep moving. Okay, so here's another case, area of an oblique triangle. So the procedure used to prove the law of sines leads to a formula for the area of an oblique triangle. So to find the area, what you have to think about is area is equal to 1/2 the base times the height. So if we take a look at this triangle right here, we go 1/2 and then our base, which is C, and to get our height, we just take A and do the sine. So the sine would be, the sine of A would be opposite over hypotenuse. So the sine of A would be opposite, which is H, over your hypotenuse. And if we solve for H is equal to B sine A. That's where that came from. So therefore, this is how you find the height of your triangle. So here is the area. Area is equal to 1/2 BC sine A. So what you should notice is that you have B and C here, and then you have the angle of A. So all your variables are going to be different. So that's what you should pay attention to. So let's give this a go. And so we're going to find, so we're going to go, the area is equal to 1/2 your sides, 52 times 90 times the sine of your angle, 102. Therefore, your area is going to be 2289 square meters. All right, your turn. Go ahead and give it a go. So pause and then come back on when you're ready to check your answer. Okay, the area should have been 213 yards squared. All right, let's move it along. We're almost there. All right, an application of the law of sines. Yay, we finally get to do a word problem. Okay, one of the things we need to think about here is you have two parallel lines. So this line is parallel to this line. Therefore, we're using alternate interior angles, which means if that's 40, this is 40. And now we can go through and we can solve it and find the length of all those sides. So I'm going to start with C. So I know that, well, I can go ahead and find my other angle, right? Just by subtracting from 180. So 180 minus 40 minus 52, which is going to be equal to 180 minus 40 minus 52. 88. So now we got our other angle. This is 88. And now I can solve for C. So I'm going to say the sine of, oops, no, wait, sorry, got that wrong. Got to put the sides first, right? Okay, so the side is 8, oops, 8 over the sine of 88 is equal to C over the sine of 40. So cross multiply, I got 8 sine 40 equals C sine 88. Therefore, C is equal to 8 sine 40 divided by the sine of 88. I'm going to plug that in my calculator. And you get approximately 5.15. Okay, that gives me C. So now I need to find A. So again, I'm going to go 8 over the sine of 88 is equal to A over the sine of 52. And cross multiply, 8 sine 52 is equal to A sine of 88. So therefore A is equal to 8 sine 52 all over the sine of 88. Plug that in my calculator. And it looks like that's about 6.3. So now if we add up all of our sides, we should get 19.46 kilometers. All right, let's move on to one. Okay, this is your checkpoint. Go ahead and pause and see if you can figure out the answer. Start it up again when you're ready for the answer. And the answer is about 1,856.59 meters. All right. Let's go ahead and fill it in. An oblique triangle is a triangle that has no right sides. Here we want B over the sine of B. And then here we want two angles and one side. Determine a unique triangle. And then the area of an oblique triangle ABC is equal to 1/2 B sine A, 1/2 AB sine C, and 1/2, let's see, what have we done? B, or A, B, oh, nope, we already did that one. One half AC sine B. All right, guys, you're done.